Hello my friends and welcome back. In this session we just want to talk about the GA parameters. As you know that every metaheuristic algorithm has own parameters, so these parameters can be important because for any given problem we have to set a specified and it's a specific parameters. So we just want to talk about these parameters and can be important and significant. So let's just get started. The first parameter in GA, it is maximum number of iteration. This could be important because we just defined our iteration based on these parameters, and then we have a population numbers. This population number and this parameter can be common between all metaheuristics, so we can see that this is quite common. So for any given problem with respect to the size of the problem, this can be changed. And we have also the number of crossover and the number of mutation. These two operators is just for GA, and we may have other types of operators for other types of metaheuristic algorithms. So these two operators will be defined based on the crossover probability and the mutation probability. And for most cases, these two parameters would be between 0 and 1 because this just related the probability of the crossover and mutation, and they just directly grasp it from the number of populations. So let's just review the main framework of a GA. I think that would be quite important because we just want to determine the role of these parameters in the GA framework. So this is our GA framework. The first of all, we have to define the GA parameters. As you know, we have the 4 different parameters for GA, and then we have to implement initializations. Actually, in this system, we just generate a solution randomly, and this is quite common for all metaheuristics. And then we have to evaluate all generated solutions in this step. So we have to evaluate all of them, and then our main loop we started for the GA. We have a crossover, and then we have a mutation, and at the end of the main loop we have to evaluate of these new chromosomes. So our fitness function would be implemented in this area, and after our main loop has done, we have to determine the optimal solution. This optimal solution would be the best solution obtained so far, and this is our main framework of GA. So for our main loop we have to use maximum number of iteration. So for crossover we have to determine the number of crossover, and this value will be obtained based on the crossover probability and the number of populations, and we have also obtained the number of mutation based on the mutation probability. And as you know, and as I told you, that these two parameters which are obtained based on the number of populations. So the number of population would be quite important because this parameter directly impact the other parameters. Here we have number of crossover and number of population. So these 4 parameters are related to the GA, and we have to define in GA parameters here. So let's just review all parameters here that we have. We have a maximum number of iteration one we just shown as a max 8, and we have a population number and we just shown as a NPOP, and we have a number of crossover NC, and we have also number of mutation, and what that we shown as a NM. Just bear in mind that these two parameters are grasped from probability of crossover and probability of mutation respectively. The number of crossover and number of mutation is quite important one, and we have to review the main procedure and main framework of the crossover and mutations. So suppose that we have 2 parents here, parents 1 and parents 2, and we here have a cut point. And this cut point would be quite important because our offspring that are measured based on these parameters would be based on these cut points. So our offspring would be something like that. For the offspring one, the first part is just grasped from the first part of the parents one, and the second part would be just grasped from the second part of parents two, and this would be happen from the offspring two. It means that we just grasped the first part of offspring one from this first part of the parents two, and second parts of offspring 2 we just grasped from the second part of parents 1. This is quite important for crossover, and we have to just consider this fact that this cut point would be important. So as you can see that the number of offspring would be even, so it is important that we have to take this fact into consideration, that we have the even numbers for offspring. Due to this fact, we have to define a number of crossover based this formula. This formula actually guarantees us that the number of offspring would be, number of crossover would be even. So we just use this formula here. But for the mutation, we do not need the even number, so we can use this in the formula here. We just round our formula. So NM would be equal NPOP multiple PM. So these two formulas is just used for determine the number of crossover and number of mutations. So let's just get back to the code and define these parameters in our code. So our parameter code would be defined in BGA. Here we just wanted to define the parameters of GA. So let's just define it. As you remember that we have a max seed as our first parameters. We just set equal to 100 as our default value, and then we have an NPOP which will be equal to 20, and then we have to determine the probability of mutation and probability of crossover. So PC and PM would be defined here, and it would be less than 1, and it actually would be between 0 and 1. As you remember, we have to define a special formula for a number of crossover to ensure that the number of crossover would be even. So 2 times round we have to round it here because we just want it to be an integer, and we have to use same formula here for NM. So we have defined all parameters here. Let's just add some comment here. So we have defined all parameters. Let's just save it and run our codes here. As you can see here in workspace that we have access all parameters related to GA. Max it would be 100, NC would be 6, NPOP would be 20, anywhere would be 10, PC would be 0.6, and PM would be 0.3. So as you can see that we didn't define the NM, so we have to modify our code here, and this is our NM number of mutation here. save it and run our code again. As you can see that we have access NMM either. So thank you very much for your attention. Let's just go to the next session.